Yeah, let me declare up. Not a Sage expert. I'm not even a Python expert. Okay, so I'll make mistakes, and some of the things that I say could possibly be wrong, but by and large it will be correct. The other thing is that I quickly went through not the videos but the slides of what has been done so far. So, so I know that you have some kind of sort of superficial introduction to Python syntax through Sage. So I want to start with this, which is the mandate I've been given, but I will try to go back and do a little bit more systematic Python, because we will need some of that to understand. So I'll start with this concept, do some of it today, and the next few classes I'll go back and maybe review some Python. So, so we have seen, okay, so since Amritanshu asked, so, oops, what did I do? Go away. Will it help to sign in? So there are two basic, okay, there is one basic thing which you have seen called a list, right? So a list is written as L is equal to 3, 4, 5 kind of thing, okay, or it need not have the same type also. This is also a list, okay. So a list is some sequence of objects, values of some arbitrary types. And one way of thinking about this is that it is a mapping from positions to values. So this is position 0, this is position 1. Right? So in a list, position 0 has value something, position 1 has something, up to the length -1. And then you generalize this to what Python calls a dictionary. Right? And the idea of a dictionary is it's like a finite domain function. Right? It has key 1, value 1, key 2, value 2, and so on. Okay, so this appears somewhere in passing in your last 3 lectures, but don't worry if you. So the idea is that a dictionary is like a list, okay, but the indices that you use to access the values in a list are 0 to n-1. In a dictionary, that index can be pretty much anything. So you can have holes. So I think the example given somewhere was for a sparse matrix, right? So if you have only few few non-zero entries, then you can specify the matrix by just giving the non-zero entries, and everything else will be automatically set to 0. So it's a much more compact way of presenting it, but this is a general structure. Okay. So one way to describe a dictionary explicitly is to. So first of all, there is this brace versus, so this is an empty list, okay, and this is an empty dictionary. So this is your way of telling Python that you're talking about dictionaries and not lists, right? And the way you would now give, one way of giving things to a dictionary is to give these things explicitly. So I can say, for instance, supposing I want the string 0. And the string 1, not the number 0, but the string 0 to be the index. Okay, so typical example is your address book on the phone, right? So what is it indexed by? The names, right? You search for some Amritanshu and it puts up a number. So it's a list of things where the index you're looking up is a character string, right? So just for triviality, let me say that the string 0 has the value 0, okay, and the string 1 has the value 1, and the string 2 has the value 2. Okay, so this is a dictionary now in Python, which where I should think about this as saying that this is like this. Okay, and in particular now there are 2 operations which are available on this. So these are, okay, so this is called a key, as I mentioned, and this is called a value. Right? So sometimes you want to do something in a list for everything in the list. So you say for I in L do something. So similarly, you might want to do something for a dictionary, right? So for instance, supposing you had forgotten to put a +91 in your telephone book, you might want to say for everything in your, every name in your telephone book, I had a +91 before it. So now how do you get hold of this, because it's not really a list? Okay, so typically you want to operate on all the keys or on all the values. Maybe BSNL has changed everybody's phone numbers, so on all the values you want to replace 2457 by 2572 or something like that. Okay, or you want to take for every key, you want to take whatever is there and put a +91 before, right? So there are two operations which allow you to get this. Okay, so there is a d dot keys which returns a list of all keys. Okay, and there's a d dot values. It's a list of all values in. Okay. Now, the point of this whole digression into dictionaries is not because I want to discuss dictionaries in detail, but at the end of this, supposing I start with this, so let us now switch over to say some. Okay. So supposing I say D is equal to.
So D dot keys, this is a list.
Yeah. It gives you a list of all the left hand sides of the colons. It gives you a list of the domain. Basically, it gives you this list, right? And d dot values gives you this list, right? So that you can operate on all elements of that list. So if you get all the keys, for each key you can look up the key value. So by the way, I should mention that. So the way I should look it up is exactly like in a list, but I use the name of the key. So if I say D2, okay, this will give me the value 2, right? So in a list you give the list name and the position should be a legal position. Similarly, here it should be a legal key, a key which you have entered, and as I go along I can then add. So having done this, right, if I now say D3 equal to 3, if it's a new key, it will just create a new key and extend the, it's like extending a list implicitly. You cannot do that in a list, right? I cannot say, if a list has 4 elements 0 to 3, I cannot say L4 equal to something and add a new list, but a dictionary you can. So if you create, if you assign a new key to it, provided it is a dictionary, it will either update that key, if that key exists, it will replace the value, or it will update it, right? So this would, so this would then produce, right? And similarly, if I continue this exercise and I say D2 is equal to 22, right? Then what this will do is it will go there and it will replace this by 22, right? So this is a kind of a very nice way of keeping track of these finite kind of lists which are tagged with a lookup value, right? Right, so this is how I do this, and if I say now D2, it shows me 2. If I say D3, it gives me an error. So this is like, if you do it in a list, you will get something called an index error. Here it's called a key error. Okay. But if I say D3 is equal to 3, okay, then that index error or the key error is no longer an error, because now I have put it in there. Okay, and if I say D2 equal to 22, then this is now this. Okay. So now the question is, now I have done this, right? So I have done some sequence of I have started off by putting key 0, key 1, key 2. Then I did key 3. Then I updated key 2. Okay, now I ask for D dot keys. Okay, so what would you expect it to give you? I mean, it should give you clearly 0, 1 and 2 as characters, but in what sequence?
The last thing added comes first.
So it is in some random sequence.
So it's not the same each time?
It's random meaning now it is the same, but if I mean, I cannot predict it from the thing that I do. So I can do some I mean, if I want it in a particular sequence, I can do things like this. Something like this maybe. Okay. But the point is that this is an example of an object which holds some data which we want to interpret in some way. We want to be able to add a pair to it with a key and a value. We want to be able to look up a key in it. We want to be able to get the list, but we are not declaring or deciphering how this is done. The point is that Python is doing this thing because it needs to look up this thing efficiently. Even if I've added 1,000,000 keys, right? If it stores it as a list and it has to sequentially scan the whole list in order to look up a particular value, it will be very inefficient. So Python does some internal storage in order to make these operations efficient. What it does to that list in order to make it efficient is not something that the person outside is supposed to know or is supposed to exploit. Maybe it is sorting on the basis of the keys, but it is not, because we saw that the keys are actually coming in some random order. So it's not sorting on the basis of the keys, but it's maintaining the keys in some structure such that when it processes the keys in that order, it produces this list. Right? So this is an illustration of what happens in these objects and classes. Right? So this was the main purpose of this. I will come back to dictionaries later on, but right now I just wanted to illustrate that there can be a difference between what you think is inside and what is actually inside. And what you're really trying to capture is not what is represented inside, but how you access the information. So there is a separation between how you access information and how it is maintained. And in some sense, your interaction with the object should not change depending, it may change in some subtle way, like it might be faster or slower, but the answer should not change. Right? So since the answer of d.keys changes, it is not something that you should apply assuming that it is in the order in which you have updated or the order you got. But you do know that at this point d of 2 is 22, right? So that should not change. So there are certain things which are expected and certain things which are unspecified, and you should not rely on that. Okay.
One question: whether the memory is continuously or
that also I cannot promise you.
can I see there is a memory allocation? Whether there is corresponding any code here?
Yeah. No. Obviously, it is using memory in some form. Now, the point is that because dictionaries are of variable size, that you can extend it, unlike a list where at least you.
No, when I am adding new element, I need.
Yeah, so the new element, I'm saying, if it does not know in advance how big the dictionary is, right, it cannot guarantee, I claim, that the dictionary is in 1 unit of storage, because either it will be wasteful, it has to allocate a lot of space for a potentially small dictionary, or when it runs out of space, it will have to copy everything into a bigger space. So usually, I believe, I don't know how it is actually done, but a dictionary will be stored in a distributed, I mean, it will be stored as with pointers, and if you're familiar with C. But the whole idea is that I don't know and I should not know. This is the whole point. Okay. So we come down back to this. Earlier thing of okay. So these are kind of implementations of what is slightly more generically an abstract data type. So a dictionary is an abstract object for us. It is something which stores these pairs k, v. Right? We don't need to know concretely how that is done. As he asked, is it done in a single block of memory? Okay, is it stored in a particular order? I don't need that. What I know is I can do certain things to this data to manipulate it, and those manipulations should be well defined, and their answer should also be predictable. Okay. So there are certain guarantees it gives me and certain things which it does not promise me, and therefore I should not rely on it. So the best way to think of an abstract data type traditionally is as a box, black box, right? Right. So think of it as an ATM. Right. So there is a slot where you can get your money out of it. Okay, and there are some buttons you can push, or a touch screen or whatever. Right. So you can update the state of the object by pushing buttons. Right. And you can ask, some of the buttons will produce some answer for you on a slip of paper. Right. So this is an abstract data type. Now, So there is a, what is inside the black box. Okay, so what is inside is hidden. Right? And what is outside here, this panel, is your interface. This is the public side of the black box, right? So this tells you what functions you can apply on it and what is the expected output given the state of the black box. Now the state of the black box, as I said, is a function of what values you put into it. What you're interested in is the logical state. That is, I'm thinking of it as a logical object. It is some collection of pairs, right? So which pairs are there, which pairs are not there, okay? And that doesn't depend, for instance, that particular state which I reached in the earlier thing, I could have achieved it by adding the keys in a different order, right? But as far as the reporting the value of a particular key, it's the same, right? So this is this public and internal thing, which is what defines this abstractness of a. So you have to then say things like, if the last update to the key was something, then the next value of that key will be that something, right? So these are the kind of, so you will have some kind of, for want of a better term, right? So if you have inserted a key for 3, then it should not come back and say key error. But if you have not inserted a key for 3, then it is supposed to come back and say key error. So these are all some properties which are, so remember that the problem about this from a mathematical perspective is that I want to describe the black box without telling you what is inside. I can only describe the black box in terms of the combinations of interactions and what they produce, right? If I can describe the inside, I can say that if the inside looks like this, then the answer to your question is this. If the inside looks like that, then the answer to your question is this. But I don't have the inside. So I have to say, if the previous sequence of operations is this, then the answer to your question should be this, regardless of how the inside looks. Okay, so that is a technical issue. That's why, so there is a whole, I mean, in computer science, there's a whole theory of how to formulate these abstract data types and make sure that you've got this thing right. But from our perspective, what we are interested in is constructing such abstract data types in Python.
So of course not all black boxes can be constructed.
Yeah. But, okay, in a sense, yes.
Very huge.
Yeah. So you are interested, okay, so basically you are interested in constructing black boxes. Now there is another part of it. The part of it is that you want to give some high level, see, so in a sense everything that you have been doing in Sage can be thought of this way. There is a black box called matrix, which allows you to take determinants and do various other things to it, right? Now, it is not necessary for you to know whether the matrix is actually just internally represented as a two-dimensional list or as something else. It may be that for certain operations, it is useful to represent it in some other form, right? So what you have is, you have a way of updating those entries. You might, in your mind, it's a rectangular array of numbers, say. So you want to be able to say, replace I, j by something. Or you might want to say compute a certain property of this thing, which is mathematically well defined, given that it is supposed to be a 2D matrix. But internally, perhaps it is storing it, storing it by columns. How do you know, right? Because you know that in Python there is only a one-dimensional list per se. So either the list can be it can be a row of columns or a column of rows, right? So it's up to you to decide how it is done. So we are. So already the kind of things that you are dealing with in Sage are these packaged objects. So you have, more complex things which I don't know in detail, but you have rings and all these kind of things, and you have certain functions which are defined depending on what is that the object supposed to be representing as a mathematical object. So that's the.
I have one question. If I have an option whether I can how to decide if I use a dictionary or list, for example, like sorting or things that I have to do, how much the complexity will differ from list and dictionary?
So I think that in Python, I think there is not much difference in complexity, but I don't know what that not much is. I mean, I think they will both be working in some n log n time, but I think a dictionary might be slightly more, but may not be. Yeah, but it may not really require that much more work. Because typically a dictionary will be stored, I mean, logically it will be stored as some kind of two-dimensional balance structure. I mean, so we'll come back to that maybe a little later on when we, right? So, so how do you do this? Okay, so I'll use ADT for this abstract data type, right? So there are two parts to this, to describing an ADT. Okay, so one is the internal I mean, what are the actual values that it maintains and how does it maintain them, right? So describing an ADT, I should be a little more specific. I'm not talking now about that abstract description. I'm saying how do I implement an ADT? So if I had to actually program an abstract data type for somebody to use, right, I have to decide how I'm going to keep the information, right? And then I have to decide on how to execute the various functions that are specified. So this is given to me. So so an abstract data type is like, it is like a contract. Okay, so you want to build a building and you architect gives you a drawing, you go to a contractor and say I want a building that looks like this. Right, now it's up to the contractor to decide, you know, how many laborers are going to work on different stages depending on what yours. I want this building finished in 45 days, then he might put more people, less people, right? So that is the implementation issue. So there is a contract which is given to you. So that contract, so we have to first, okay, so we have to do this given a template or a blueprint. Right. So basically we are given some abstract specification and then we are supposed to implement it. Now when we are doing actual programming, this abstract specification is more informal than formal. I tell you that I want to represent, I want to a black box which does a matrix, two-dimensional matrices, and I expect you to be able to compute typical functions like determinant, rank, whatever on this. Now you have to decide therefore on what is an implementation, and then we might haggle about what are the functions supposed to look like. What is the name of the function for I mean, do you want me to write determinant or is DET enough? Okay, and then am I allowed to give you certain options? Supposing I say give me the determinant of this part, so am I allowed to specify a part of the matrix and ask you for the subdeterminant of that part? All these things we can negotiate, right? But so I'm saying that the blueprint from the contract perspective I'm not talking about. Okay, so it is what we expect the abstract data type to do is something we will agree on informally. Okay, so I think the best way for me to do this is to do a small example, and so I'll start with that and then we can see what to do. Okay, so we need to, so here is my example that I thought of. Okay, so supposing we want to represent just Cartesian points x comma y, okay, and then I might have operations such as, okay, maybe so distance between 2 points could be an operation, I mean a natural operation. I might want an operation which allows me to modify a point. So maybe I want to, given a point, I might want to apply some delta x, delta y and move it somewhere else. Okay. It's a third. Okay. Now, distance from origin we can reduce to this first case by always providing 0, 0 as a point. Okay, but we might be, I want a separate function which tells me how far it is from the origin. Okay, so these are all type of things that I might want to do. So now the natural thing would be to, obviously the most natural thing is to store as a part of the point the two coordinates x and y, right? And then all these operations will be in terms of x and y. Either they will update x and y, or they will return some square root of x squared plus y squared. Or now the point of the first one is a bit tricky, right? So I have 2 points, so it's a kind of symmetric thing, right? So I have to ask for distance between 2 points. So normally in a conventional kind of thing, I would write this as some distance which takes 2 arguments, 2 points, and returns them. Okay, but in this abstract data type formalism, the function is attached inside. It's a button on the box, right? So I'll have this distance function either on the box called P1 or on the box called P2 or both. But the point is, I don't have an other function. I don't want another function outside which takes 2 boxes and produces an answer, because that box will not be able to look inside in general. Okay, that function will not. So this is where we have this funny terminology that you have seen in many of these things. So I'll say something like P1 dot distance and pass it P2. Okay, or symmetrically, because they are both the same type of thing, I will have a function. So each point will have a distance function inside it, which allows it to take another point and compare it to that point. Okay, so this is just some way of where that syntax comes from. The syntax is that you don't have a function which takes 2 different objects, but rather the functions are inside each object and they can take arguments which could be another object of the same type. Okay. So the way you do this in Python, so you first use a class to define what I will call the template. What does a typical point look like? Okay, and then you will instantiate these classes as separate objects, right? So in this object oriented terminology, okay, a class is like the same thing as a type. When I say int, okay, int is a category of values that I can manipulate, and then there are specific ints. There is 7, there is 5. Then if I say x equal to 2, then x becomes an int whose current value is 2, but I can replace it with another value later on, and so on. So similarly, now once I use a class, I create a new type of value called point. Then I can say P1 is a point, P2 is a point. So these are all specific objects, they are all separate. Okay, just like L1 is a list, L2 is a list. If I say length of L1, it is not confused with length of L2. It's a property of L1. It's not a property of L2. Similarly, if I have dictionaries, there are many dictionaries. Each of it has its own set of keys, its own set of values. The same way, every point will have its own x coordinate, y coordinate. It will have its own distance from the origin. And if I take 2 such things, I can compare them in terms of the distance from each other. Okay, so that's what an object is. An object is just a concrete instance of a class. Okay, so okay, so typically this is what a class definition looks like. Right? So you give the word class, just like functions are using the word def or define. A class is defined using the word class, then the name of the class. Okay, so you have to give a new name for this. Is a new type of value that you're going to manipulate. So you should not be confused with any given value. So, and it's conventional to use a capital letter, but I don't think it's obligatory. Okay, but it shouldn't start with the. It should start with a letter. Okay, and then you give the definition, which I will come to in a minute. And then what you will say to start some dialogue on this is that just like you have a way of saying that L is a list by saying, okay, so you will use the name of the class and then you will give this bracket which I will come to in a minute. Okay, so what this tells Python is P1 is indeed a point. So henceforth all operations available on points should be allowed for P1. Otherwise P1 has no type. So Python is a bit different. I'll come back to this in another class. But Python is a bit different from many programming languages in that the names themselves don't have types. P1 doesn't have a type. P2 doesn't have a type. You don't say upfront like in a language like C or C++ int x float y. Okay, so in most languages you declare upfront what the type of every name that you're going to use in the thing is, and then you are stuck to that name. Python names are free. They assume the type of the last value assigned to them. So today x could be an int, tomorrow x could be a float. Okay, it's not a good programming practice to do this, but as you go along, the current value assigned to x determines what is allowed on it. Right? So that type is enforced. If you have something that is not currently a list and you try to do a list operation, it will say sorry. But few lines later you can assign it a list value and then proceed. Okay, so here you need to be able to tell Python therefore that P1, though it has no information contained in it at the moment, it's like an empty list, but it is of type point. Okay, and similarly you would say something like P2 is of type point. Okay, so perhaps you might have, now how do you assign values to it? So let us, the simplistic values, supposing I am allowed to provide at any given point the x coordinate and the y coordinate. Okay, so I'll say, supposing I say P2 dot something like this. Okay, so this might be a function which is given to me. Okay, so what this means is somewhere here there must be a definition of a function set value, okay, which will take this and do some right. So to understand how to write and use these functions, we need to know how to define them inside. So they are pretty much like normal Python functions, but they have a slightly different one twist is there.
The last bracket maybe take some values also.
Which one?
P1 is equal to 2-dimensional point or 3-dimensional.
Yeah, I'll come to that. Yeah, so at the moment I'm just giving the most basic thing, but we will come to that. You can make that thing.
So this is just a question about the way we write things in Python. So when you write a class and you want to call a function from that class, so you type the class dot.
Correct.
So
correct.
instead of that, you can do this. You can first define the object as.
Yeah. So the class dot the function, okay, is typically useful only if the function is a kind of external function, like math.sign, right? It takes it produces the answer from its argument without updating the argument or looking at the argument, right? Whereas if you have a non-trivial class like this, right, so the function depends on the state. So the function set value applied to P1 is different from the function set value applied. So this is like P1's copy of set values. So you should think of each point, each instance, each object has its own private copy of this function, and you're calling that copy and not, you're calling P1's copy and not P2's copy. So you don't normally call in these kind of definitions the point dot set value, because point dot set which value, which set, which point are you setting. So you have to fix a point and it will set the value of that point, right? Okay, so now what I just said was that every function will be invoked in the context of an object of that type, right? So when I say P1 dot set value, it is different from P2 dot set value in the sense that whose value is being set, right? P1 dot set value set my value if my name is P1, P2 dot set value. So there is some context, and that context is inside the class. You use I mean, so in kind of human terms, it uses the special name self to refer to itself. Because now when I ask you distance, for instance, you will have my own x and y values and somebody else's x and y values, right? So somebody else will have a name. I will be asked, what is my distance from P2? So I will know that I am looking at P2's x value and P2's y value as compared to my x and my y. So what is my y called my x value? It's with respect to this special name called self. Okay. So as a consequence, every function that you write inside this class definition will always have by whatever syntax, the first argument will be called self.
So just the class point, they should be open, close, and fixed.
I don't believe so. But maybe
doing that.
no, I don't know. Maybe it's possible. It's very eminently.
Oh, if it's a base class.
Only if you're deriving from somebody else.
Yeah, yeah. So I think normally if you're getting, because that will come to later on. There's inheritance and all that.
Okay. I didn't realize that.
Yeah.
Yeah, it works without that.
Yeah. I mean, I did that. So in the morning, just to verify that I knew a little bit about this before.
I guess we've always been deriving from something.
Yeah.
Not,
Yeah. So normally you're not starting from scratch. Yeah.
we've not been bold enough to define base classes.
So the function that I'm going to call from outside, so let us not confuse. We'll pass two arguments which I'm interpreting as the x coordinate and the y coordinate that I want to assign to this point, right? So there will be an internal way of storing that thing. So that's what I meant by saying that every point must store some state, right? It must store some values which with respect to which it can answer questions, but you have to be able to update that state also, right? So if I ask you the distance from the origin, it will be the square root of my x squared plus my y squared, but how do I get that x squared plus y squared? That is through this thing. So the function that I called on the other side said, say p1 dot set value, what was it, 6 7, huh? 6 7, right? So this will work in the normal way, except that it will start with the second argument, right? So 6 will go to A, 7 will go to B. There's always a special first argument called self. And now inside the thing, typically, so this is the usual function. Okay? So everything else is normal except that this self is required. Okay? So this is so this by example. I have decided that internally I will use two names x and y to refer to the x and y coordinates. So I will just assign the x value to be A and the y value to be B, but I want to emphasize that it's my copy of x and my copy of y. Okay, because each point has its own copy of x and its own copy of y. So I must refer to it in terms of this dot notation saying the object dot the value. Okay, so it is x and y, but not somebody else's x and y. It's my x and my y.
That's something I don't know. Even if
Yeah, once I'll just write this in. Yeah.
so here inside something, so we know like we get the things we
Yeah.
are calling also. So why do you need to say that?
Yeah, you don't need to say this. If there are some languages where the self, if it is unambiguous, is optional. Okay, you only need to refer to self if you are, or rather, okay. So the problem arises again because of this, the lack of declarations. If you have a language in which you announce in advance that I am going to use the names x and y as internal things of type int, then if I say x, I know what I am talking about because I have already announced in advance I am going to use x. I have already announced, but Python doesn't announce in advance. Names just pop up.
So I think
Right?
the difference between saying x equals a and self dot x equals a is that one is just a variable inside this thing and the other is an attribute.
Yeah, exactly. So the point is when it comes to a name, say when it comes to a name, the problem with Python is it has no predefined way of knowing whether that thing is supposed to be local to this particular object or it is just some random thing floating around. Right? So when I use I can write a loop inside this thing for I equal to, so those things are just some things which come and go. Okay, so that is the problem. So Python basically says that if it's an attribute associated with the class, you must use the word self, so that it preserves this when next time when the thing comes around, other things will get destroyed and change and things like that. Right?
Yeah, so that is a different memory allocation than that.
Yeah.
Because
It even has a different.
because it's kind of a copy.
Yeah, correct. So in some sense, okay. So you can think about this as two parts. That there is a part of the memory which is dedicated to remembering information about P1, right? And then when you are manipulating things about P1 by calling a function, some other variables are used. Now those variables will be used and then discarded. They will kind of a fresh copy will be created inside that context, and when that computation ends, it will be thrown away. And but P1, whatever part of it is updated, will remain updated. So P1 kind of persists. The other part is transient. And they might be very well in different blocks of memory, right? So the moral of the story is that you have this self. I mean, so far this, okay. And now, okay, now the thing is that you are not supposed. So the mantra we came up with is you are not supposed to know what's inside. So technically, sitting outside, you are not supposed to know that inside it's called X and Y. Now Python does not enforce this. So Python, it's more like a, I mean, it's like OMR before there were traffic signals. So people are supposed to be polite and observe the rules, but they are not enforced, right? So you can actually go out and say P1.x, P1.y, okay? But in other languages like Java, you can say you can only ask me for information and I will tell you what I will tell you. So you can ask it, please give me the value of x. It may or may not give you that. So just as an example, okay? So supposing I did not do this. Supposing for some anticipating some other need, instead of this, okay, and assuming I had done other things properly, I don't know. I have no idea what the function is called in Python, but let us just say it is. Right. So I could choose to represent it in polar coordinates for all you know. You asked me to set x and y, I set r and theta. Now functionally it should not matter to you. You ask me for x, I will come back and I will say r cos theta. You ask me for y, I will give you back r sin theta. You don't know whether inside it is r theta or is xy. So every computation you do, and maybe I do this because now I know that you're going to ask me distance to the origin, I'll just give you r. Okay. So this may be a design decision that you choose a certain representation anticipating that certain operations will become cheaper later. Okay, but you don't tell the outside world exactly what you do. And this is what the dictionary is doing. It's storing those keys in a particular structure because it knows that as the keys grow in some arbitrary way and they get updated, it will have to keep answering questions about is this key there, what is the value and all that, and needs to be able to efficiently look it up. And the way it efficiently looks it up is, it's like, you know, why are books in a library put in some Dewey Decimal classification? I mean, why not sort by alphabetical order of author? Okay, because the chances are that people who are looking for one book on calculus and don't find it will look for another book on calculus, and they'll be next to each other, and it's not clear that this will be useful if the whole library was sorted by author. Right? So there is a certain use or certain anticipated use of this thing for which you arrange the information in a particular format, which may not be the most obvious format that comes to you the first time. So the same thing with classes. And the nice thing about classes, the whole point of this class issue is that you might realize this later on, right? So you might implement a dictionary keeping things as they come. It works fine. And then suddenly it becomes hugely popular, and you know, Amazon starts using your dictionary to store its warehouse. And they say, boss, it takes me 2 hours to get any answer out of it. And then you go back to the drawing board and you fix your dictionary. But Amazon does not have to fix their code. It's the same code. They are still calling DK, right? But you have changed your code so that their answer is faster, right? So the interface is unaffected by the implementation. That is the big kind of requirement of this abstract data type. So you can start with a naive implementation, okay, such that you can go ahead now you believe that you have this point and all that, and maybe you can write some other code which assumes that you have these operations or something, and verify that that works. But later on you go back and say, oh, now, but there's something going wrong, it's very slow, and you find that the bottleneck is in some way of computing something about the class that you have designed. So you go back and you fix that, but you fix it in such a way that only the internal structure is changed, and now it's crucial that that guy does not rely on the fact that you're using XY. Now, if he has been cheating outside and using x and y in his code, p dot x and p dot y, and you change it to r theta, then his code is going to go wrong, right? So that's why you should not look at the implementation. You should only look at the functions that are given to you as legal ways of accessing and updating the data. So ideally, so coming back here, okay, so you could, I mean, Python does allow this, because Python believes that all programmers are well behaved. You can say and achieve the same effect. But the first way will work whether I'm using that self.x, self.y or self.r, self.theta. Whereas if I change from this to this, the second thing will stop working. Okay, so this won't work. Right? So this is the issue. So you don't want to. Okay. So this much is clear, right? So Python does allow this. I mean, I want to emphasize. So now maybe we can do this. Go away. What is it? Set. So this is some. So if you have a function which does not, supposing I just want to report back the values. So I want to return the pair of values x comma y. It takes no arguments, but in this class thing, it will take one argument self. Okay, so the self, you have to remember, if you don't put self, then it has this. So somebody asked this question about point. You asked this question about point dot. Okay, so functions which have self as an argument are functions which are tied to the object. That is, they are always called with respect to an object, and they have access to the state of the object as self. Functions which are defined without self are like any other function. So they don't have any built-in starting point. They only get whatever information they get from the arguments. Okay. So in our context, every function will have self, but that's a distinction. Similarly, if you have a variable, like you said, okay, you could have variables actually which don't say self dot something, and they are things which don't belong to a particular object. Now it's a different issue whether, I'm not sure in Python whether you can have a variable like this which actually persists. So supposing you want to keep track of all the points you ever created. So you say p1 equal to point, then it sets the value of this, but it says counter is 1. It's like, this web page has been visited 2,476 times. Right? You say p2 equal to point, it sets its thing, but it updates its counter to 2. So at some later point, you can say, is this the 1000th point? If it's the 1000th point, do something. Right? So whether that particular thing can be stored in the class or not, I'm not very sure. Some languages like Java have it. I'm not sure whether Python has it. But in general, if you don't put self dot something, it means that that value will not be stored as part of that point. So it will be lost when you come out of that point. Okay. So
can you inside the class define functions and then use them for?
Yes, you can. Yeah. So you can have the usual thing of defining functions which are just used as helpers. That can be done.
So those functions will be stored as part of the class? but they will not.
Yeah, but they will not be available as p dot f, I think. I mean, all these things are gray areas. All these things are gray areas because Python has, as I said, a very polite way of dealing with this thing, and so it allows you to use things which you should not be able to use. Anyway, so this is my thingamy, right? New point dot py. Right? Oops. So if I do, so you are aware, by the way, that there are these two versions of Python going around, and we are because we are in Sage, we are using the old version because most of the mathematical things in the world are written in Python 2. There's not much difference as far as.
2.7 is faster than 2.4.
I would not say that, but it's just that most of the code that people have written, especially scientific and mathematical code, was written at a time when Python 3 had not been developed, and it's not obvious to just Python 2 code does not, unfortunately, not compatible. You cannot just take Python 2 code and run it in Python 3. So you have to keep track of this fact. So this is 2.7.8. So they only increment the third decimal in this, whereas Python 3 is incrementing the second. It's 3.5 now, I think. So yeah, today I saw 3.5. Till yesterday it was 3.4. I mean, today when I went to look at the documentation, it offered me 3.5 documentation. Somewhere it showed me some. I forget where it is, but anyway. Anyway, so the point is now I can say from. So this is the usual way I can insert code from existing things. So I can say from new point. Hopefully all is well. Right, so this is what I did. It has no
Set point.
Oh, set. Oh, sorry. Thanks. Right. So notice that this is a function with no arguments, but in my code, it was defined with self. Right. But now, what Python allows me, and it should not, is okay. So this should not be allowed, okay, in object-oriented, unless it is explicitly given. But then what this means is that you have two options. One is you make everything not allowed. That is, all internal variables can only be accessed by giving you a function saying, give me the value of x, set the value of x. Give me the value of y, set the value. So every function you have to write every variable that every name that you use inside the class, you have to provide a function to update it and to report its value. Okay, programmers don't like that because that's very slow. In the sense that it's tedious in terms of number of functions you have to write and number of right. So if you don't allow that, if you want to give programmer shortcuts and you want to maintain privacy, then you have to have two categories. Those for which this is allowed, these are called public, okay, public names, and private names which you don't want the guy to fiddle with. Okay, so if you ever written a Java program, okay, so the smallest program you can write to say hello world says public static void main. Okay, so public private in Java is referring to whether or not outside people can refer to it or not. So you have to declare not only whether something is an int or not, but whether it is public or private. And so you have all these different qualifiers which you have. So the static refers to what I was saying earlier, saying does this variable persist across classes or is it destroyed when the class is left. So this is a variable which is not a part of the class. It's not like x and y, like some loop variable I. But does the next iteration of next time I use the class, does I retain its value from the previous time or not? So that is static. So this public static void main in Java. So public is the public private, static is that this function persists, it's not a part of the class, it always exists. Void means it returns nothing and the name of the function is main. Right? So you have a lot of syntax that goes with that, and Python is trying to minimize on syntax, no declarations. So everything is public. Okay. So in Python everything is public. Right. So now we are almost at the 1 hour mark. So how long should I go on? It's not that I have any specific agenda to finish because I've got lots of lectures, so I can.
Lunch is until 12:45.
Okay, so maybe I'll just go on for 5 more minutes if I can remember what else I wanted to say specifically now. So there was something. Okay, so then this question came up saying that at the very least, let me do this. Okay. So right? So why should I say it's, I mean, like a list, right? I can say L equal to blank, empty list, and then say L equal to L dot append 1, L dot append 3, and so on. But it's also useful to say L is equal to square bracket 1, 3, 4, 5, right? So can't I just start off by saying that this is a point whose x coordinate and y coordinate is 6, 7? How do I do that, right? So I want something like, and this is the reason why you have that bracket, right? So you can provide optional arguments at the time of creating an object, which will be used at the time of setting it up. So basically, when I say p1 equal to point, what is telling Python is keep space for a point for me called p1. Now this is saying in addition populate it with some values that I am providing you. Okay? So the corresponding thing in the other side is that it must do something. Right? It's not def class. So there is a special function which goes by the strange nomenclature of underscore, underscore, init, underscore, underscore. Okay, so this is an initialization function. So this will be called automatically when this happens.
So by this we are not like using that set point.
Yeah, no, we can still have the set point, but this is implicitly another function which behaves like set point. We can still have an auxiliary function which allows us to change the point later on. I don't want to create a new p1, but I want to arbitrarily move p1 from somewhere to somewhere else, not just shift it by delta x, delta y, but maybe
How does it differ?
it differs in the sense that it will just update the current point to have a new xy coordinate. Whereas this one is a one-time thing, which though this init is only, you cannot explicitly call init. Init is called only once, and that is, see, this statement is a one-time thing saying create a new space in memory of type point and call it p1. If I do it again, I am destroying that thing and creating another place. But if I already have one and I don't want to change it, for example, I could have a list of points. Now supposing I want to change the coordinates of the 5th point in this list without creating a new point there, then I might want to just use that set point. So both can coexist. They are not replacing each
I
other.
have one comment.
Yeah.
You can call init, but you never should. I mean,
Yeah. So,
Python.
yeah, it's a Python thing. Yeah, I agree.
You can say p1 dot underscore underscore init
Yeah, so-
underscore underscore.
So it will not be listed as a public function of that point, but you can call it. So this is,
Public will be shocked if you do it.
yeah, so these are all, as I said, right? So in our context, there's no difference between the working of init and set point, because it's just setting the point. Okay, but the main thing is that this is implicitly called, so that's the reason why this creating an object has brackets, because you can provide arguments to it, right? And when you call it, when you call such a function with the brackets, it will have this. But now, okay, so supposing we just do this. So it's conventional to write this up front because it's a special function which okay, so this is, so it's identical to the other one, right? Okay, another thing which if somebody could tell me how to do this, I'll be great. But if you have already called that stupid file and you have changed the file, you can't do it again. You have to get out of Python, get in and call it again.
In Sage, you can do run file.
Yeah, but in this, I don't know of any way to do it in the Python interpreter. So I'm re-importing Python because the earlier functions were different. So now if I say p1 equal to 0.6, 7, it works, right? But if I say p2 equal to, okay, so you live or die by this, right? So if you say that points must be created with values, points must be created with values. Okay, then don't give me empty points. Right? So next we'll come, maybe in the next class I'll talk about this. How do you give default values? Right? Supposing you want to allow this also. Say that perhaps you, no, because the point is that once you do this, once you have provided the user with the ability to set the value at that time, If it does not provide, then you have to assume that there is a value. What value? So typically you might want to say that any unspecified point is initialized to the origin, right? So this is a general property, nothing to do with this class business, but in functions in Python in general you can do this. You can give default values. Okay, so you have functions which seemingly take different optional arguments, and it's not that the arguments are optional, but rather that if you omit them, then some default value is given inside the definition. Okay, so just remember this, right? So there's so I'm just changing this to some, you can't see that, but I've called it r theta point. Okay, so as I said, so first of all, I think I should do that, otherwise I'll be in trouble. Is this right? Right, so as far as the user is concerned, they are getting this thing, right? And now I'll have to make sure that this is different, right? So this x and y now are these transient things. They are not part of my state. They are just some intermediate values that I created, right? Now I claim that from the user's perspective, nothing should change, assuming I have not messed up the Python part of it. So first of all, so what is it?
Or maybe math.8.
Yeah.
Okay. Not very good. I mean, I always screwed up something, but so this is not a, but you get the point, right? So you see the, so is it b by a, is it right? Should be b by a.
That's correct.
Wait, what is?
Okay, dot is more.
What's 6 by?
Maybe self dot are inside the dot.
No, it's giving me identical values. It's already dangerous. So let's.
What is the division?
There's something wrong.
Doing integer division perhaps?
Yeah, but a slash should be normal division whether it's integer or not, unless.
Now, if numerator is an integer, it will take the integer division.
Yeah, I think that's.
No, I think that. Oh, this is. No. I'll tell you why. Because this is.
Oh,
Okay, so this is not the same. So this is the problem. I'm currently teaching in my other class. I'm teaching Python 3.4, and this it's not the same.
And stage also takes same.
Yeah. So basically, so yeah. So this is okay. So this is the problem.
Stage
Then
will give you exactly the value. Numerator is an integer.
Generally 7.5 words. And then it should say dot.
yeah, Sage will not do anything.
So yeah, that is means if you give real numbers, it will give the exact.
this is better. Okay.
Point has changed a bit.
Yeah. But anyway, so Right, so this is the idea now. I mean, so obviously normally I would not assume they're integers because it's the arbitrary points, and so within the precision I'm working, hopefully everything will work out. So this is just to illustrate that the implementation can change and keep the interface essentially unchanged. Of course, there will be this kind of minor things, but more importantly, it will typically be for efficiency reasons. As I said, you initially keep some list in some as it comes order, but then later on you decide to sort it or rearrange it in some efficient way, and that should not break the implementation. I mean, it should not break the interface, right? But now, obviously, if I do this, okay, then, okay, so so this is another brilliant thing about Python. So the point is that it should give me an error, but what I think what Python has done is it has freely associated a new value called x with P1.
Oh, even if it's not defined.
Yeah, but the only thing is that x is never used inside P1, so I can use it externally for whatever I want, but it's not going to be used.
That is possible.
No, see, because Python doesn't enforce this public and private thing, right? So this is, I mean, you learn something new every time you try something wrong in Python. But so by default, it should not be there. You see, Python.y doesn't exist, right? So if you ask for the value, it will not exist, but it freely allows you to set a new value by that name without changing anything inside. So it's the important thing is it's not doing what you expect. So if your code was relying on the fact that setting p1.x is the same as providing a new xy value to the thing, then your code will not work anymore, because you'll be happily going along thinking the point has changed, but it is not changed because you're not working in that mode, right? So you should not. So Python expects the documentation of the code and the user of the code to be disciplined enough not to exploit this, to know the boundary of use only the functions which are given to you as public and don't rely on the names provided inside.
Likewise, I guess the documentation should never mention anything that is not public, right?
Yeah, correct. So that's why, for example, if you look at the documentation of dictionary, it will not tell you the dictionary type. It will not tell you anything more than how to get that list using keys and values. It doesn't tell you internally what is the exact data structure it's using to store that thing, right? So it doesn't tell you d.k is the list of keys or something like that. So that's fine. But if it's like Sage, where or some public thing where you would like the implementation to also be shared with the user so that they can, if necessary, update it or modify it or something like that, then that person necessarily has access to the implementation whether you like it or not.
Is there a way to check if two dictionaries have the same set of keys or not? I guess
We'll do it at the list level.
then you have to see one list with the permutation of the other.
Yeah, or you sort them and check for equality. I mean, that's
Yeah.
yeah. So checking whether two dictionaries contain the same data is not trivial. Right? So this as I said, when we'll have to look at what it means, say D1 equal to D2, it means different things in different contexts. So that's to do with Python and not so much to do with object-oriented. Right. So this is the basic introduction to classes. Okay, what you can do with classes. So there are some other auxiliary things that we will do, and on the way I would like to go back and review how Python in general keeps track of names and values, because sometimes you have. So you have seen this notation, right? I don't know if you have seen this notation, but you know what this means?
Yeah, 8 times, 8 zeros.
Yeah. So
the 64 zeros. So it's no, so 8 zeros of again 8 blocks.
right? No, I'm assigning.
So second element will be. Yeah.
Right, so I've taken the 0, 1, 2, the third list, third thing, it's second essentially, but whatever. So what is the value of L?
You have 2 ones. 1. Oh my god.